The polar ice caps are melting even faster than we previously thought, and we had no idea. So how did it come to this? Tiny organisms called ice algae appear to be the hidden culprits. Despite their microscopic size, they exist in massive numbers across vast areas of the Arctic and Antarctic. Normally, the ice caps act like giant mirrors, reflecting sunlight back into space and helping to keep our planet cool. They're essentially Earth's natural air conditioner. But there's a problem. Current climate models that predict ice melt often ignore the role of these algae. Ice algae darken the surface of the ice, making it less reflective. This means more sunlight gets absorbed, accelerating the melting process. And that could have far-reaching consequences for our climate. In this video, we'll explain why these overlooked algae pose such a big threat, and what that means for our future. Ice algae live on, in or under the sea ice. Every year when the sun returns to the Arctic, the warmth triggers a bloom. These blooms are very important for Arctic ecosystems because they form the base of the food chain. Climate change has mixed effects on these algae. A longer warm season means that they also have a longer growing season, but when the ice completely melts, it leads to a shorter growing season. Thinning of ice and snow cover increases the light availability and has a positive effect on the algae. In total, scientists think that the algae will be able to expand their range. However, climate change not only has an effect on the algae, but algae also have an effect on climate change themselves. Algae blooms color the ice darker with green, pink, or red colors, and ice with these colors has a lower albedo than white ice. The albedo effect is the amount of sunlight that gets reflected by the surface. If more light gets reflected, less warmth will be absorbed by the surface. More algae means more colored ice, and thus less albedo and more warmth, accelerating climate change. This is essentially a never-ending feedback loop that could possibly speed up even more, leading to rapid melting of the ice caps and global shifts in climate zones. Recently, scientists found that the algae have a much better ability to store phosphorus, which means that they can also live in nutrient-poor environments. This means that there will likely be even more algae blooms. This can drastically alter the total albedo effect of Earth and cause more global warming. The problem is that all models used by climate scientists don't incorporate the effects of algae, and that climate change can therefore be severely underestimated. Why is it so important to include the impact of ice algae in climate models? As mentioned earlier, these tiny organisms can significantly increase the amount of solar energy absorbed at the surface. This additional energy accelerates the melting of ice sheets as it raises local temperatures. And when this melting occurs, which is not a question of if, but when it can trigger a cascade of consequences for human civilization. We're talking about rising sea levels, disruptions in ocean currents due to changes in salinity, and major shifts in polar ecosystems. These are not isolated effects, they ripple out and impact the global climate system. It's therefore so crucial to deepen our understanding of how these microscopic organisms influence ice melt. Their effect extends beyond the polar regions and plays a role in shaping the Earth's climate as a whole. More than ever, we need researchers like you to study this phenomenon and to communicate its urgency to the broader public. Because in the end, people will only take action when they understand what's truly at stake.